All right, this is number 6 for one of the forms. I'm not sure if it's number 6 on all of them, but on your multiple choice part of your Unit 3 exam, let f be the function with f of 0 is equal to 1 over pi over 2, f of 2 is equal to 1 over pi over 2, and then we have this derivative. How many values of x in the open interval 0 to 2 satisfy the conclusion of the mean value theorem for the function on the closed interval 0 to 2? So remember, the mean value theorem says that if your function is continuous and differentiable, which we know this is differentiable because the derivative exists everywhere, and if a function is differentiable, then it must have originally been continuous, then the mean value theorem tells us there will be some moment c where your instantaneous rate of change is equal to your average rate of change over the interval, right? So this is the IROC equals AROC. Instantaneous slope equals average slope, derivative equals old school slope, and also the slope of the tangent line equals the slope of the secant line. All right, great. Well, I already have f prime. Let's find f prime of c. F prime of c would be c plus 1, and the cosine of pi times c, right? If we're going to actually follow what the statement directly says, f of b minus f of a is going to be 1 over pi squared, and b would be equal to 2, minus 1 over pi squared, and a would be equal to 0. So we end up with is c plus 1 equals the cosine, times the cosine of pi c is equal to, this ends up being 0, is the slope of our secant line. So actually this is kind of more of an application of Rolle's theorem, but that's okay too. Mean value theorem is just a more broad Rolle's theorem. So I'm going to set c plus 1 equal to 0, and I'm going to set the cosine of pi c equal to 0. C is equal to negative 1, but we're only supposed to be looking on the interval from 0 to 2, and negative 1 is not on that interval, so that one we're going to throw out. The next one I need to consider all of the places where cosine is equal to 0. Well, cosine is equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, etc. going forward, but then also we could have spun backwards, so negative pi over 2, and negative 3 pi over 2, and we could keep spinning in either direction. So this means that each one of these angles is equal to this part in here, right? Pi c, oh, my pen died, pi times c. So to solve for c, I'm going to divide all of these by pi. So we end up with c equals 1/2, 3/2, 5/2, negative 1/2, negative 3/2. But really what we'll notice is that this is out of our interval. We're only supposed to be looking between 0 and 2. So our c values, there are 2 of them where the mean value theorem would be true. So again, what that means is there are 2 moments where the slope of our tangent line is equal to the slope of our secant line. If you're struggling with this part, you might want to go back and review from pre-calc in Khan Academy. The solving of trig equations is what this skill is. Solving of trig equations, if that's the part that tripped you up on this problem.